Okay, on to question 4, which is questions about optimization. So part A, at what level, local, interprocedural, or interprocedural, should we apply the function inlining optimization? Justify your answer. So for this one, we have to remember local means like sort of in a single basic block. Intraprocedural means in a function where we might have multiple basic blocks in some control flow. Interprocedural means between two functions. And so this is a little bit of a tricky question, but really we'd say interprocedural here because we are inlining functions. And so we are changing the control flow or the call graph for the entire program. We are, potentially removing, function calls from the application, and we are then therefore doing this at sort of an interprocedural level between two functions, right? We're working with the entire piece of code in order to function inline. So that's what we would say here. What three factors do we consider when applying optimizations? So there's safety, cost, or cost / risk, and last one is profit. So roughly the same as if you're investing or something like that, right? We're making sure that it's safe to apply this optimization. We want to know what the risk is. So for example, loop unrolling increases the amount of code we have, or function inlining might increase the register pressure. So that's the risk, and the profit is that we don't have to make a function call, or we can do two things at once on a superscalar processor, right? So then on to part C, define the following optimizations, 2 points each. So this is just, really just definitions of these optimizations. So instead of writing here, I'm just going to talk through each of them. So dead code elimination is where we remove code that is no longer used. Inlining would be taking the body of a function and inserting it into the place where the function call is, thereby eliminating the function call. Loop invariant code motion is moving something outside of the loop. Loop unrolling is expanding the number of iterations of that loop, and then and sort of not expanding the number of iterations, but doing two iterations in sort of one iteration in order to increase the number of things you can do at once. And tail call elimination, we talked about that in the optimization lesson. This is where we try to get rid of recursive calls, things like factorial, n-1, where we call the same function again with just one less, and we try to turn those into iteration instead, thereby eliminating a bunch of calls. So that's it for question 4.